these issues. So there's 7 themes to our lectures. The first, which is today's theme, is pre-construction surveys for birds. The second, which will be in about 3 or 4 weeks, will be on pre-construction surveys for bats. After that, we'll have a lecture on post-construction surveys for birds and bats. Then there will be a lecture on estimating detection rates, another lecture on mitigation, finally, a lecture on regulatory and policy considerations, and then a conclusion lecture on best management practices to ameliorate or mitigate for negative wind-wildlife interactions. Jill and I introduced these lectures a few weeks ago in Astana and in Almaty in Kazakhstan. And we are thrilled to be able to present our first lecture on pre-construction surveys for birds. Our first speaker is Elisha Müller, who will be introduced by Jill. Before I hand it over to Jill, just a reminder, please mute your microphones. And then also, Elisha will be taking questions at the end of the presentation. So please write down your questions and wait till the end. Jill, do you want to introduce Elisha?
Sure. Welcome, everybody. Todd, Eliona, Yenlik, and others from Aspika are so pleased that you're joining us today. It's very heartwarming that you've decided to spend this time with us. Our first speaker for the virtual component of our lecture series is Elisha Müller. Elisha is a conservation biologist for the North Dakota Game and Fish Department. North Dakota is one of America's states that's probably the least visited of all the 50 states and is very remote. And in that, I think it has a lot of similarities with the country of Kazakhstan. North Dakota also has a lot of wide open spaces and grasslands, much like Kazakhstan's steppe. And so we have a wealth of species and habitats here. It is Elisha's job as a conservation biologist to protect those habitats and those species. I also live in the state of North Dakota, and so I know Elisha very well. We work very closely together on coming up with ways to protect our grassland habitats and especially birds from the impact of wind energy development. So I am very thrilled to be able to introduce you all to Elisha. And I thank her very much for accepting this invitation to share with you the knowledge that she has gained in developing wind facilities in a manner that protects the biodiversity of animals. So with that, Elisha, I will turn the mic over to you.
Thank you. I think I'm going to have somebody share the screen for me and we can jump right into the presentation.
There we go.
And you can go ahead to the next slide. So I'm going to start with a little bit of background, and I'm going to take this from a lens of my state that I come from, North Dakota. But like Jill said, I think there's quite a bit of similarities from where some of you are all from. So you can take this and extrapolate it to what you're familiar with. In North Dakota and all the states here, we have what's called a state wildlife action plan. And what this is a guidance document for conserving our state fish and wildlife species, and specifically our species that are most unique to our state, and the species that are rare and declining. So it's our blueprint for conserving those species. And in North Dakota, we have 115 species of what we call our species of conservation priority. But we are actually currently in the process of updating this plan, and 2025 will be our next update. And we will probably see quite a few more species. We will be adding a lot more insects. So we're probably going to see a lot more than 115 species on this document. So we've decided that the best way to protect all of these species, rather than taking 115 or much more than 115 different approaches to protect them, is to protect the habitat, because a lot of all these species depend on similar habitat, for example, grasslands. So you can go to the next slide. So when we start working with developers, one of the first things we do is we provide this map. And this is that first step in high level planning. And I think Todd had mentioned that you guys will be getting a reading list, a PDF. And in that list, there is our best management practices. And we go into detail how we created this map. I'm not going to go into that because that could take this whole presentation. But if you're interested, you can look at our best management practices, and it goes into detail how we created this map. There's a lot of layers, wildlife spatial layers and habitat spatial layers. But what this map is showing risk to our habitats and our wildlife in North Dakota. So the areas in the dark gray are where a developer might find that there's higher risk to impacting native wildlife and the habitat they depend on in our state. And then the areas in the lower or the lighter gray and then the white, there's lower risk. And so when they're first starting out looking for a project, they would want to maybe avoid the darker gray areas and try to land in the white areas. And so that's the first step. You can go ahead to the next slide. And so when we start with our pre-construction surveys, back to that first thought, is we want to do that native habitat desktop survey. So once they get that project boundary determined, a habitat analysis should be done to determine what the unbroken habitat in that project boundary is. So in our state, the main habitats that we're focused on is the grasslands, the woodlands, which we don't have many, but we do have some, and then our wetlands. And the reason why we want to do this is once they start locating turbines or roads or the other infrastructure, we want to avoid these pieces of habitat. You can go to the next slide. And so there's a lot of layers, and I'll go through some of these, but there's a lot of spatial layers that they can use when developing this survey. And so we'll go through some of these, and most of these are publicly available. Some of them they can get through our agency, North Dakota Game and Fish, to do this survey analysis. So this is one, this is called the puddle layer. So this is potentially undisturbed lands. So everything on this map that's a light green or chartreuse, that's potentially undisturbed. So an unbroken grassland. That darker green is a disturbed grassland. The brown is a cultivated crop, and the purple is a shrub. And so as I go through these, you can kind of see where they all line up. So everything in most of these that's brown is a cultivated crop. So you can kind of see how they line up in all these different layers. And so as a developer builds these maps, you can kind of see how the layers build on top of each other. So this is just one layer that they can use. You can go to the next slide. So this is the national land cover data. Again, that green is some kind of herbaceous layer or a grassland. That yellow is a hay or pasture land, and the brown is a cultivated crop. You can go to the next slide. This is another layer, a similar layer from the United States Fish and Wildlife Service. Again, the light green is the native vegetation. The darker green is some kind of introduced vegetation, likely some kind of hay or crop, and the brown is cropland, cultivated crop. You can go to the next slide. This is a national cultivated layer. So this is a layer that shows something that has a crop history, cultivation history. So the green is a non-cultivated, so grassland or herbaceous cover. And the brown again has some kind of cropping history, cultivated land. You can go to the next slide. This is the Conservation Reserve Program. So this shows in the dark gray something with a cropping history. And then the light gray is undetermined, which means it does not have any type of cropping history. So it could be broken. It just doesn't have a cropping history. So it's considered undetermined. And the purple is CRP, which means it was once a crop, but it has been planted back to some type of grassland. You can go to the next slide. And then another very useful tool is to look at aerial imagery over time. So in these different photos, it's the same piece of land over time. You can see like the bottom left corner and the top right corner, you can see aerials that, or you can see images where cropping has been done. So you can see areas where the land has been tilled and areas where crops have been grown. So we can verify that those pieces have been cropped before the land has been broken. But we can see other areas where it has not been broken. So we know that land is native grassland. And so we get to adding all those layers together, we get our final analysis. Oh, can you go back? There we go. So we get to our final analysis. And so it looks something like this. And so we have the green, which shows our unbroken grassland, our orange, which is that restored grassland, which used to be some type of crop, but it was planted back to grassland. The blue is inconclusive. So in most cases, a company, if they plan to put something on those pieces of land, they would go out and do ground truthing. So they would either go out to that piece of land and figure out if it had been broken or not, or they would speak with the landowner. If it was a landowner that was participating in the project, they would ask if it was cropped or not. The brown is cropland, and those black small spots are farmsteads. So in this case, we would, again, the green is really that habitat that supports our rare and declining species, our grassland birds, our pollinators, our specialist species that we are most concerned about protecting, especially in blocks like 1, 6, and 7. Those large connected chunks of grassland, those are very important for our species of conservation priority. Those are the chunks of habitat we really want to protect. And so those are the areas that we really want to avoid putting development on. And so we would strongly recommend development stay off of those pieces. And we would push the developer, or highly recommend the developer move development onto the brown chunks of the cropland, or even onto the restored grassland, even though a monetary investment went into restoring those. It would be better to break that back up than to break up unbroken grassland, because once it's broken, it can never go back to that unbroken state. So we would rather see those pieces be retaken out than breaking those big chunks of unbroken grassland. So that's why this is our, our first and foremost, most important step in pre-construction surveys. We want to see this analysis done first. You can go to the next slide. Okay, and then we have our species-specific surveys. Even though I said we don't really do species-specific, we do have a couple in some cases. You can go to the next slide. So in one of those cases, oh, I fixed these slides. I don't know why they're showing up like this. Go ahead back. So we have a couple grouse species in North Dakota. So we have sharp-tailed grouse, we have sage grouse, and then we do have some prairie chickens. So for sage grouse, we actually know where every active sorry, I got muted there. Yep. So for sage grouse, we know where every active lek is in North Dakota, so we don't really need to ask developers to do surveys. And for prairie chickens, we don't really get development where they are. We have very few. They're very far east in our state. We just don't really see development in the same area where prairie chickens are. But sharp-tailed grouse are everywhere in our state. They're a very popular game species, and about a third of the entire population of sharp-tailed grouse are in North Dakota. So North Dakota is a very important state for maintaining the population of sharp-tailed grouse. So it's our job to really protect this species and do good for them. So managing them properly, it does fall on our shoulders. And so we know we got to do, we have responsibility for sharp-tailed grouse. And so it's important for us to make sure that when development comes, we're asking them to do pre-construction surveys for them. And we know that protecting nesting habitat for sharp-tailed grouse is important to maintain healthy populations. And females tend to nest within 2 miles of a lek. So knowing where leks are and avoiding development near them is the best strategy to protecting the species. And like I said, there's a sharp-tailed grouse all throughout North Dakota. And we have a very small wildlife staff here, and it's very hard for us to know where all the leks are. You can go to the next slide. So we do what we call census block surveys. Go ahead to the next slide. And in this photo, those yellow squares are where we survey in the state. So you can see that's a very small snapshot of the greater part of the state. So when our surveys line up, go ahead to the next slide. When they line up with a project like this, for example, we are able to share our data with the developer. So this is an example of that. So that yellowish, orangish square is where we survey for leks, and that gray dashed project boundary south of it, that's the that was a proposed project boundary. So all of the black dots were leks that we had found and we surveyed, and then the project boundary was below it. So we were able to share with that developer that here's where we survey leks, here's leks that we know of. We could pretty much assume leks are pretty well tied to grassland, even though you can see, so the green is the grassland. You can see there are some leks in the white. So there are leks that do fall in, stubble fields or on cropland, but they do usually end up on grassland. So you can assume that there's more grass in the project boundary than there is in that square that we surveyed. So you can assume that there would be about as many or more leks in that project boundary than there are in the area that we surveyed. So we would expect the developer to find at least that many leks in that project boundary. So when they surveyed for grouse, we would assume to see a similar result, and we would hope, or we would recommend, that they would avoid all of those leks by that 2-mile buffer to help protect that nesting habitat. You can go to the next slide. Another pre-construction survey that we recommend is raptor nest surveys. Aerial raptor nest surveys we recommend should be conducted twice during breeding season, but they also can be done pre-breeding season to identify stick nests and post-breeding season to identify the species and occupancy. And the reason that we recommend these is because we have buffer recommendations. And so we recommend avoiding these nests by certain buffers depending on the species. And so doing these surveys before construction and identifying where these nests are allows the turbine locations to be placed outside of that buffer zone to avoid impacting those nests and those species. You can go to the next slide. Okay, so all of those surveys that I had just went through were ones where we do recommend the developer go out or the developer's consultant go out and do survey work out in the field. The next ones I'm going to cover, these are ones we recommend using existing data and doing more modeling or survey work that doesn't involve survey work out in the field. And the reason why we recommend this is because we are lucky that we have a lot of data at our fingertips to use. And that might not be the case for everybody in this call. That might not be the case for every other state, but it is the case for us. And so I don't know if my recommendation for you all or for everybody else would be the same for us, but so I guess you would have to consider if you would take this route or not. But for us, we used to have pre-construction data for some of these species where they would go out, for example, not whooping cranes, but my next slide, grassland birds. We used to have pre-construction data where they would go out and do point counts for grassland nesting birds. And sometimes the data was underwhelming. Quality was maybe not always the best. And I hate placing blame, but sometimes you get really great scientists to go out. You get, really avid birders that know their stuff that go out and do these surveys. But sometimes you get a seasonal technician that's a college student that doesn't know their birds that well, that's hired for one season to go out, and the quality's just not there. And so the detection rates are just not there. The quality is pretty low, or you get a drought year where the species aren't using the habitat like they typically would, and it's a very small snapshot compared to what might be there over a 10-year period. And so you're not really understanding the true risk of what development might be for the species that you're concerned about. Whereas we have data sets over 10, 20, 30 plus years that give us a better idea of what the risk might be to these species. And so we've decided that it's better to use these data sets rather than having somebody go out and take a small snapshot of what's out there at that specific time. But if you do not have these large data sets, getting an idea of what's out there at that specific time might still be better than having no data at all. So that's just a precursor of that. But this whooping crane data, so this model here, I also think this is in your, this paper here that goes into this model and how it was created is in your PDF if you're interested in reading more about how this was created. But it's put together, it's a spatial modeling, or it was generated using spatial modeling techniques from digital land cover information from satellite imagery, the National Wetlands Inventory, whooping crane observations from the Cooperative Whooping Crane Tracking Project. And so it gives us a strong indicator of whooping crane presence. And so the red is high likelihood, down from blue to green. And so whooping cranes, I don't believe have ever been hit or ever been killed by a turbine, but I believe there's only maybe 600 birds in the population right now, somewhere around there. Jill, you can correct me if I'm wrong. It's not very high. They're one of the rarest birds that we have. This is their migration corridor through our state. And I just don't want to be the one to cite the first wind project that kills the first whooping crane. So we really want to be responsible when we place development. We want to take this seriously. And so it's really important to, look at these models, really understand the risk when we are placing development. And if we're looking at, high likelihood of whooping cranes stopping through the area, we need to make sure, we're understanding if we think there's going to be a strong indicator of whooping crane presence based on, decades-long data of whooping crane presence versus that short snapshot of if a whooping crane was heard the previous year or not. Go ahead to the next slide. And then again, I used this as my example before, but instead of going out and doing those point counts for breeding birds, we have several different models and data sets for breeding birds that we lean on. But we think that the native unbroken grassland analysis that I went through earlier is our best predictor of grassland bird risk due to development. So if the native unbroken grassland is there, those grassland birds that we are concerned about are there. There's, I believe, 30 or so grassland birds on our list of 115 species that we're concerned about. So if there's grassland there, at least one of those birds that we're concerned about are gonna be there. So this is the United States Fish and Wildlife Service Habitat and Population Evaluation Team spatial models. Again, this is in that list you guys will get if you want to read more about this. But these are strong indicators of predicted occurrence of grassland nesting birds. And this is just an example here of a couple different species. And so we use this as just predictors for species within the state. You can go to the next slide. And then this is another example. This is the United States Geological Survey breeding bird surveys. So these go back decades, and this is just one example of one of the species of concern. We have the Baird sparrow. And again, this is just decades old data of grassland nesting birds that we can pull and look at what the data looks like in our state. You can go to the next slide. And then for, excuse me, breeding waterfowl or breeding duck pairs, this is what's called the thunderstorm map. This is again that habitat and population evaluation teams. They developed spatially explicit models for breeding duck pairs with over 30 years of waterfowl data showing breeding duck pairs density per square mile, with the red being the highest density down to the blue. So this is all data that I said, again, we have, decades of data that we can pull from instead of looking at that short snapshot. So all of these models are available to developers that they can pull from, and they can run their analysis for their project boundary, looking at risk this way rather than going out and doing that field work. So you can go ahead to the next slide. And then finally, our last survey, pre-construction survey that we recommend is something that maybe isn't the typical pre-construction survey. And this is what we call an impact analysis. And before I get into this, really, I want to just briefly cover the impacts that we're going to talk about. So you can go ahead to the next slide. Go ahead. Thank you. So in North Dakota, so far, we have lost about 2,400 acres of habitat to our rare and mostly grassland for our rare, unique, and declining species. So this is just an example in those photos of turbines and roads created in our native grasslands. You can go ahead to the next slide. Another impact is collisions. So some estimates, 3 to 6 birds are killed per megawatt per year. And that for North Dakota specifically is about 12,900 to 25,800 birds killed per year. And there was also specifically a study done in North Dakota that showed 30 species of birds are killed in grasslands versus 9 species in agricultural lands. And so that shows that, you know, we are always trying to protect our grasslands because we know that's where our rare and declining species are. That's where our specialists are. You know, it's the generalists that go into the ag fields, the ones that don't really have those specific needs that need to be met. They can, you know, kind of survive off of those disturbed lands. And so it's not surprising that there's only, you know, 9 species in the ag lands, but there's much more in those grasslands, 30 different species compared to 9 in ag lands. So we're killing a lot more species in the grasslands than we are when we're placing the turbines in ag fields. Go ahead to the next slide. And also another study showed in 2012, there was about 366,000 bird deaths a year. And that was approximately 44,577 turbines in operation. In 2021, there were approximately 65,548 turbines. So that would equate to approximately 538,000 bird deaths per year, up from that 366,000. And that was 2021. We're only going up from there. So each year we're increasing greatly. And these numbers are likely underestimated. Again, going back to that detection rate, we know we're not finding all of the birds out there that are being killed by these turbines. A recent study found that dogs that search fatalities are finding 6.4 times and 2.7 times higher bats and small birds respectively. So dogs are actually finding way more than what humans are able to find. And they're actually doing some studies now using drones to find fatalities at wind turbines and seeing if they are able to find more carcasses that way as well. So these estimates are probably way lower. There we go. There we go. That's okay. This one's good. Okay. And then lastly, so then our last impact is, so those ones that I just listed, sometimes we refer to as our direct impacts. And this here is sometimes what we call our indirect impact. And so the direct is that habitat loss and the collisions. It happens right away. You can see it, you can quantify it, but the indirect is a lot harder to see. It's a lot harder to quantify, but it's still just as impactful. It still impacts the species, it impacts the populations, but it's long-term. It's that avoidance and that displacement. So if you look at these two pictures, you can kind of see it a little bit better. In that first picture on the left, you have all of these happy populations here. But then when you put these 600 feet turbines in, you know, they're tall, they are almost constantly rotating, they cause shadow flicker, they have sound, they cause stress to these birds. Sometimes, you know, with that shadow flicker, they think there's a predator nearby, or the sound, there's stress. And so these species tend to avoid these areas and they move away. And so even though that nearby habitat has not been broken or lost, they find it unusable. So it's still there, but they're not using it. So that habitat becomes lost. And so those species move away. And so in some cases, if the other surrounding habitat is already at maximum capacity, these species don't really have anywhere else to go. So they might not be displaced, they might just be lost. So that is a decrease in the population. And so that could have population-wide impacts. Oh, go ahead back, sorry. Go ahead to the next one. Okay, yes. So this analysis, this impact analysis we asked them to do, this should be done as a pre-construction survey after the final turbine is laid out. And we asked them to do this as an estimation of the impacts that the project will have on wildlife and its habitat. And this is done because it can help determine if voluntary offsets should be recommended. And so in North Dakota, this says necessary. I should not say necessary. We don't ever say necessary. We recommend that if habitat is impacted, we recommend that they should offset for that habitat. So if our grasslands are impacted, or if our wetlands are impacted, we recommend that those should be offset. So in this picture, in this example that I was using in that habitat analysis earlier, those red dots are the turbines. And again, that block 1 and that block 7, those were the areas that I had recommended that they avoid. They put 1, 2, 3, 4, 5, 6 turbines in those areas. That's some pretty big impacts. And so Jill Schaefer on the call, she has done a study in North and South Dakota, and it's had a huge impact for us here. Her and Deb Buell found that 7 of our grassland nesting birds declined or was displaced about 52% within 300 meters of turbines over 5 years after turbines went into grasslands. So we lost 52% of birds within 300 meters. So when turbines go up into grasslands like this, we put that 300-meter buffer around them, and we recommend a 52% replacement or offset. And so if 100 acres are impacted, we would recommend 52 acres be replanted after. So we don't really talk dollars in North Dakota, we talk acres. And so we recommend habitat be replanted as an offset here. And so that's why this habitat analysis is one of our most important pre-construction surveys, because we want to see every time our habitat is chipped away, we want to see something put back on the landscape. Go ahead to the next slide.
you should press, нажать F5, и тогда запустится презентация.
So this is just an example of what one of those habitat analyses look like. So all of those black triangles are turbines. The circles around them are that 300-meter buffer. The green within them is that unbroken grassland. So everywhere the unbroken grassland falls within that 300-meter buffer. And then the purple is the unspecified grassland, but we don't really worry about that. So in this specific case, the acres of the unbroken grassland that are impacted is 500. And then the waterfowl, I don't really get into this, but that's that model I had talked about earlier. That thunderstorm map, it's a model that the developer can run on their own, and it outputs the duck pairs that are displaced. So they can do that. It's very simple. They can just ask the habit team for the model. And in this case, it was 17 duck pairs displaced. But yeah, so this is the impact analysis. And once they have this done, then we can make recommendations on if offsets should be considered or not. And next slide. And I think with that, I will take any questions. I have a question already. Could you give an example of offsetting? Yeah, so when we talk offsets, again, we're looking for habitat replacement. So we don't want to talk about, specifically in North Dakota, we don't want to talk about dollars. So if it's grassland that is broken, we want to see grassland restored. And we are specific. We do want it to be replanted with species that are native to North Dakota. If it's wetlands that are impacted, we want to see a wetland restored. Or if it's a native woodland that has been impacted, we want to see woodlands restored. And we try to keep it within the same location in the state or the same kind of like habitat. So if you recall the map that I had showed earlier, that gray map, what's called the coteau, which was that area where the our coteau is like the wetland complex area where the whooping crane migratory corridor was. It's just a complex of wetlands and grasslands. It's really important for waterfowl, for migratory birds. So if development were to happen there, it's just a very specific habitat. If some development were to happen there, we would want to see restoration happen there. So we try to keep our restoration offsets in an area that is fundamentally similar to where the impact is happening as well. Hopefully that answers the question. What is a lek? Oh, I'm sorry, I should have covered that a little bit better. So a lek is where grouse display and dance to attract mates. So they do like a little dancing ritual, and it's where they attract the females to come in to attract a mate.
Thanks.
Yes.
May I ask a question?
Yes.
Oh, hi, thank you. I thought it would be a little bit quicker to just ask rather than type it. So I'm calling from Scotland, and one of the approaches that we take in our casework is to encourage developers to site turbine infrastructure in commercial forestry plantations. These are non-native tree species planted in such a way that they're very low biodiversity value. But we tend to find that our developers are quite reluctant to do that because I think there are additional infrastructure considerations with putting it in forestry, and also because then they are obliged to offset the loss of trees caused by the infrastructure going in and costs associated with that. I just wondered, for example, if your developers are using non-virgin kind of grassland sites like cropland, how do they respond to that request, and what policy is in place in terms of how they need to sort of reimburse landowners or any sort of cash value associated with that ground?
Yeah, so I would say we don't have a ton of trees in our state, but I would say similar to you, our biggest issue is we try to keep them out of our native grasslands and push them into cropland, because that is the broken, areas. And our biggest issue is our landowners don't want to farm around a turbine, just because it's an added hassle. And so that is the biggest hurdle. And so, yeah, we do have that issue that developers try to blame us from the beginning. And so instead of working together and going in and saying, hey, we would love to put a turbine in your crop because this is the most or the least impactful way to do this development. We could protect wildlife, we could have green energy development. This is a win-win for your state. They'll go in and say, well, we have to put it here because Game and Fish is making us. And so it paints a picture, and it puts, the state wildlife and agency against the landowner, and it makes tension from the start. And I wish that there was a way to, work together from the beginning. And it's just a battle that we've been fighting for a while. We're working on it, but it is difficult. The landowners do get, compensated either way. We're trying to figure out ways to, there's a ton of programs in the United States to take crop out of crop and plant it to grassland. So we're trying to figure out ways that we can, and then there's also other programs where we can, leverage with the wind development. And then there's the whole offset where we can, restore to offset wind development. So we're trying to figure out ways where we can work with a landowner that might be unhappy that he has to move a turbine off grassland and put it in his crop, but there's no easy answers. So yeah, it's definitely a difficult topic.
Thank you. That's really helpful. Thank you.
Yeah. I have another question in the chat. If you'll give me a second, I'll read it. Do you do seasonal surveys for migratory birds? We do not do surveys for migratory birds. I think earlier I had said we have a lot of data sets at our fingertips, decades old data for things like breeding birds, for waterfowl. We just have a lot of data that is available to us that we can use. But I had said earlier, not everybody has that kind of data. And so I think it's, each state, each country is different. It's dependent on what data that you have available. For us, just because we have this data available, it's better for us to use it because it's a long-term data set. It's more reliable for us to look at a long-term data set and decide what the risk might be to species, rather than a 1 or 2 year snapshot of what's there that might be, altered depending on the weather, the climate. It might not really tell us what the risk actually is. But if you don't have long-term data sets, a 1 or 2 year snapshot might be better than nothing. You're welcome.
Are there other questions or comments? Well, Elisha, thank you very much for that fantastic presentation. I will send some applause. I think all of us appreciate the insight and the guidance. For those of you who are interested, we had at least 78 people on the call today. We will be doing our next presentation will be on pre-construction surveys for bats. Elisha focused on birds. In the United States and in Europe, bat surveys are at least as important. Impacts to bats are at least as important. And so we will spend our next lecture on that. I think that lecture will be in about 3 weeks. Let me get the, one moment. Let me get the exact date for you. The exact date for that will be the 14th of November. And we will send an announcement out just like this one. And our speaker will be Amanda Hale, who is from West Incorporated in the USA, in the state of Texas. And Amanda has done years and years of research on bats and wind energy. Jill, are there any other things that we need to cover?
Yes, I would just like to say if somebody thinks of any more questions, they can email me, Todd, Eliona, or Yen-Leek, and we will either answer them for you or we'll confer with Elisha and get you the answers, because I realize, you know, we covered a lot and you may want to view the slides again and listen to the recording so that you may think of questions later on. So feel free to email any of the 4 of us with any other questions that you think about. We'll be happy to answer those. The second thing, if you would note in your chat that Yen-Leek put it was supposed to be a pre-lecture reading, and Todd and I apologize for our delay in getting you the pre-lecture reading. It wasn't so much pre, but it is out there, and it is a document on how the North Dakota Game and Fish does their avian and bat surveys. It is taken from the state of Minnesota, which is our neighboring state to the east. That was meant to be your pre-lecture reading. I think it was pages 10 to 21. In addition to that, we will be sending out the list of resources that Elisha referred to in her talk. So we do have that PDF ready to go that, you know, gives all of the information, the hyperlinks that you can download and read that and access that material yourself. So I don't know if Yen-Leek, maybe you already put that in the chat, but if not, yes. Okay, so Yen-Leek just put that in the chat. You can download that right now. There are additional questions. So somebody asked about bladeless generations of turbines. Otherwise, I think that's the last question. Someone asked if the presentation will be uploaded. So Yen-Leek, maybe will the presentation be uploaded on the Aspica website? Can you answer that question? Okay, yes, we will download the recording on the website. The bladeless generation turbine, would that possibly be a better way to conserve bird biodiversity? I'll take a quick shot at that. It possibly will reduce collisions. I would expect that bladeless turbines would reduce collisions. What it will not reduce is the issue of displacement. Birds that are avoiding wind infrastructure are still going to avoid wind infrastructure, whether those turbines have blades or not, most likely. So I don't know, Todd or Elisha, if you want to pick up that question as well.
I would imagine that, yeah, collisions would be reduced. I would imagine displacement would be reduced if there's not huge rotating blades. I guess it would depend on what the megawatts would be per turbine, and what habitat loss would be if the megawatt is reduced greatly, and you would need a lot more because it's not producing as much megawatts as each turbine. So I'm not quite sure. I would assume if they would be able to produce as much megawatts as a turbine and they don't have huge rotating blades like a turbine, I would assume it would be quite the win, but I would have to see what it looked like when they were able to develop it. I would
It
think
might
it would
also
be a win
depend
to
on-
biodiversity, though.
Yeah, it also might depend on how tall those studies would have to be done, right? We would need to do studies to know for sure. Todd, are you on mute?
No, I think those are good points. I think we do have a problem in North America with collisions with communication towers, the tall towers that have mobile phone and radio antennas. And so tall towers for wind turbines may cause a similar problem if they're not done correctly. But that's my only thought about that. As Jill said, if there are other questions, feel free to email any of us and we can get you answers. Likewise, with the list of references, if you have trouble getting any of the papers, send us an email and we can send you a PDF of the papers. I think that's probably it. Jill, is that correct?
Yes, I have nothing more to add other than a huge thank you to the U.S. Embassy, Chevron, Aspica, and everybody who took their time to participate with us today. Thank you.